In this lesson, we're going to discuss NetFlow and Flow Analysis. Now, as you've probably guessed, packet captures can take up a lot of storage space, and they can quickly grow in size. For example, if I wanted to conduct full packet capture on my home network each day, I would need several gigabytes of storage just for my small family because every single packet that goes in and out of my house would have to be captured by that network sniffer. Every video game my son is playing online, every YouTube video he's streaming, every Netflix show that my wife is binging, all of that is going to be captured frame by frame and bit by bit. This is known as a full packet capture. Now with full packet captures, also known as FPCs, you're going to have to capture the entire packet, including its header and its payload. Because full packet captures take up so much storage space though, there are many times that we don't want to collect it all because this can be a waste of a lot of resources for us. Instead, we can opt to use flow analysis to collect the most important details about the traffic being sent. Now, flow analysis relies on a flow collector, which is a means of recording metadata and statistics about network traffic rather than recording each and every frame that's passing over the network. The flow collector can then sample the network traffic and provide statistics to our flow analysis tools for us to be able to observe. By collecting this metadata about the data itself, we can save a lot of storage space and minimize the processing costs as well. Now, the downside of using flow analysis instead of full packet capture, though, is that we won't have the content of what we sent over the network. We only have information about that data. For example, if I had a list of every phone call you made today, I would know who you called, when the call started, how long you talked for, and when the call finished, but I wouldn't have any idea of what you said during that call. That's the idea of metadata, when we collect things about the information. And so this kind of metadata we collect when dealing with flow analysis is going to be dealing with what kind of traffic was sent. If it was HTTP, HTTPS, FTP, SSH, or some other protocol, and how much of it. Now, all of the flow analysis information that's gathered can then be stored inside of a database and queried using different tools to produce reports and graphs. Flow analysis is wonderful for highlighting trends and patterns in the traffic observed, and it can create alerts based on anomalies observed in those traffic patterns as well. Flow analysis can also quickly create visualizations to map out the different network connections, the traffic types, and the volume of each session or connection. This can be really useful in identifying different traffic patterns that might reveal bad behavior, such as malware in transit, data exfiltration, or other suspicious or malicious activity. NetFlow is a Cisco-developed means of reporting network flow information to a structured database. This was actually one of the first ones out there, and eventually it became the standard that everybody started using under the name IPFIX, or IP Flow Information Export. Now, IPFIX is going to be used to define a particular traffic flow based on different packets that share the same characteristics. For example, we could set up a traffic flow based on the same source and destination IP that's being used to signify there is a session between two different hosts. Now, this is the data flow between two hosts, and we can gain some information about it. Then we might have a second data flow for anything communicating with a particular domain name, and we can collect information about that data flow too. Now, as we look at the data collected by NetFlow, we're going to find information about the packets that was sent, including the network protocol interface being used, the version and type of IP being used, the source and destination IP addresses being used, the source and destination ports being used, or the type of service being used. All this information can be gathered and then analyzed visually using these different tools. For example, here on the screen, you can see how SolarWinds tools are used to display the collected NetFlow data of a network. Similarly, you can look at it in a more text-based manner by listing out the data flows as one and going all the way down to flow 15 in this little snippet. Here, if you wanted to see what each one had inside of its flow, you would click the plus sign like I did next to flow 15. And you could see the source and destination addresses, the source port and destination port, and some basic information about this particular data flow. Notice though, you're not getting any of the actual content of the packets that were inside of that traffic flow, because NetFlow only shares with you metadata about the data. This is because you didn't collect the full packet captures. Now, if you want the best of both worlds, you can use a tool like Zeek. Zeek is a hybrid tool that passively monitors your network like a sniffer, and then it can log full packet captures based on data of potential interest. Essentially, Zeek is going to sample the data just like NetFlow, and it's going to use a flow collector to do that. But then, Zeek is going to log the full packet capture whenever it finds something interesting based on its filters or signatures. This allows us to go back and analyze the full packet capture for those items collected, without wasting a ton of storage and processing on other data that's passing over the network. Zeek also does a great job of normalizing all of this data for us by storing everything in either a tab delimited or JavaScript object notation or JSON formatted text file. Now, once you have this normalized data file, you can then import it into other tools for visualization, searching, or analysis. For example, here I've taken the Zeek logs and I've imported them into Splunk, and now I can search for specific information during my analysis of a potential incident. Another useful tool when dealing with flow analysis is the Multi-Router Traffic Grapher, or MRTG. Now, this tool is used to create graphs that show network traffic flows through the network interfaces of different routers and switches by pulling those appliances using SNMP, the Simple Network Management Protocol. This is extremely useful because we can see patterns emerging based on the volume of traffic being sent or received. For example, in the top graph of the router firewall, where do you see a big spike in traffic? Quickly, you should be able to identify there is a big spike in traffic between 2 a.m. and 4 a.m. Now, the question is this normal or is this suspicious? Well, maybe and maybe not, but it's something we should probably go and analyze further to see why are we seeing this big traffic spike between 2 a.m. and 4 a.m. This could be something normal, like doing offsite backups to the cloud. That would be a reasonable explanation. So if I was responsible for this network, I would check with our offsite backups and figure out when are those performed. But if I don't do offsite backups at 2 to 4 a.m., then I need to figure out why is there this big traffic spike there. Maybe it's because our database is being exfiltrated due to a malware infection, and it's sending off a copy of our entire database at 2 to 4 a.m. each morning, and that way, when system administrators are at home sleeping, all this data is being stolen from us. Now, by just looking at this graph, we don't know what the reason is for this large spike in data transfer, but we do know we should investigate it because it could be anomalous, as you're seeing here the rest of the traffic for the day. Now, another thing we can do based on this spike is if we determined it wasn't an offsite backup and it is suspicious, we might want to set up a network sniffer in front of this server and see what traffic is leaving and where it's going. Based on that, we can then dive deeper to see exactly what is happening and identify other indicators of compromise based on the PCAP data and the flow analysis that we collect.